Good. So I think it's now time to start. Even we have not all registered people online, but yeah, we have to be in time. So again, my name is Marcel. I'm Director of Learning and Development at Hikvision. Previous, I was responsible for the product management team in Europe for Hikvision. So now this have changed a little bit, and my intention today is to give you some small introduction into thermal technology and the place inside security and surveillance. And basically we'll quickly go through the presentation. If you have any kind of question, please put it in the chat or in the Q&A section. And my colleague Frank, he will try to answer it during my presentation. So thermal imaging. I think everybody knows a little bit about, but from the historical point, thermal technology was developed after the Second World War, basically for surveillance of night vision or surveillance of borders and other areas during night. And basically today you can split the whole thermal technology market in two sections. One is the imaging itself. So for the security market, just to create an image out of the contrast of the different heat radiation of the different objects. This is very useful to detect a person which is climbing over a fence or which is running through an area during nighttime, during daytime, under bad weather conditions. So this is imaging. We just create an image out of the radiation. And this is typically for security. In the security market, you can also find other kind of thermal solutions which are not uncooled micromillimeter long wave infrared, which is what we have as a technology in our cameras. So you can also find short wave infrared cameras or mid wave infrared cameras, but both of them are more cost effective, not cost effective, more expensive, and also the maintenance and handling of the systems are not as easy as long wave infrared. But they have some advantages, like a mid-wave detector camera have a much larger detection range. It can go up to the 23, 25 kilometers, so very, very ultra long range, but for sure also ultra big money you need to spend off. So it's easily to spend 100 or 200K in one system. So we are talking today only about the long wave infrared. This is an uncooled microbolometer detector. This is the most cost-effective technology. So for the volume market, for the mass market. The main applications in security, for sure, is the perimeter defense, perimeter protection, and also for area surveillance. Another big part of thermal technology is thermography, which is it's based on the same physics for sure, but we are not taking just the radiation and making an image out of it. We also taking the radiation and with some additional parameters to the camera, we are calculating a temperature of an object. And by getting temperature of an object just by the heat radiation, you can use this kind of tool for test and measurement, for temperature monitoring, for safety reasons, so fire prevention and detection. And so it's a very big market, but the cameras are not measuring the temperature. The camera is measuring the radiation and calculate the temperature out of it. And these camera systems are typically used for buildings, for insulation problems, or HVAC, like the floor heaters and other kinds in the building industry, but also for electronical. So if you have a electrical cabinet and you have to detect, you have some struggling problems in resistance and some overheated parts, you can use a thermography camera to detect this issue on the cable connector, on the fuse, on the relay, whatever. You can detect it easily without touching it, without stopping the system, without shut it down. So it's a non-contact maintenance tool, and it's very common since many, many years. Some other applications are like medical wise, so for the medical science and R&D applications. But it's still, I'm working nearly 20 years now in thermal imaging, and every week somebody calling me and ask me about an application, if it's possible to do with a thermal camera. And still I learn a lot in where you can use a thermal camera. And during this training, you will see some of more of these applications where you can use a thermal camera. In the past, these two markets were very separated. So you had a security market for thermal imaging, and you had a test and measurement market. The markets, the applications, the products, the cameras, and for sure the customers and users are different in both markets. There's a big difference if you have a security company who's who's doing perimeter defense, and you have another engineer who's taking the thermal camera for test and measurement of a building. So it's complete different markets and different products as well. Today we are talking about security, basically about the imaging, but also we do the step into the safety world for the fire prevention and detection. And all our cameras, the security cameras, have the possibility to calculate the temperature out of the radiation, with some limitations in temperature range and accuracy. But for safety applications, there's no, I would say there's no need for a more accurate camera, but for the most applications, you don't need the accuracy of ±2 degrees. So let's go on. Very simple, 2 glasses of water. In both glasses is water inside, but we cannot determine on the visual spectrum. So with a visual camera or with our eyes, we are not able to see the temperature of the water. And with a thermal camera, it's pretty simple. I mean, in this example, I don't like this example. I need to make some new pictures, because on the left side, you see the condensation. So everybody must be clear, on the left side is a hot water inside, hot water, cold glass, we got condensation. So we got the water drops on the top of the glass. But in a thermal image, we don't need to calculate the temperature out of it. We just see right is cold and left is white. So it's hot, very simple to see, but it's not possible with visual technology to see this temperature difference, heat radiation difference on the same object or on similar objects. Very old videos, but still explain a lot. On the left side, there's some visual recorded camera stream, and on the right side, there's a thermal recorded video. One information on the right side, normally in security and surveillance, you're using white hot as a color palette. So that means from black, cold to white, which is warm. In this example, they change the polarity. So black is hot and white is cold. This can be very useful if you're looking on a cold surface to determine the hotspot. If you need to determine the hotspot, it can be very useful when you change to black as a warm color, especially over lakes, over water surfaces, over snow. So for search and rescue is also very helpful to detect a human inside a snowfield. It's much easier with black hot palette. And the reason is that our brain is more easy to find a black spot in a white surrounding than a white spot in a black surrounding. So it's not related to the camera technology or to the physics. It's just to determine our brain work, how our brain is working, and detect some objects. On the left side in the visual video, I'll just restart it again. You didn't see the person in the background. One reason is it's getting dark outside, so it's 7 p.m. here in this example. It's still a little bit bright, but not really. So you are not able to see the person. Up to that point, he's flashing on the flashlight, and then you can see it in the visual spectrum. There is something. Also, we have some issues here with light reflections from the lamp, and all of them we don't have in the thermal image. What we see here is just a temperature contrast. So we have warmer materials, heated up materials. I think this is a wooden poles, and the wood is absorbing the heat from the day longer, so it holds the temperature, the heat inside for a longer time compared to the grass, for example. The grass can heat up fast and also cool down fast, but a piece of wood is heating up slower, and also later it's emit slower the temperature, so it holds the heat for a longer time. I see the question with cameras being used here. I mean, this is a B spectrum. I think it was a 2235 at that time. So it's a very old type from 2016. It's end of life for a couple of years already. But it just gives an example about it has a 384 resolution on the right side, and on the left side, I think it's the pre-version of the Darkfighter. So a little bit longer all the time. But it's not really necessary. What you can also really good see here is we didn't see the visual light effect. So the lamps, which we see here in the visual image, we didn't see in the thermal because we are not detecting visual radiation. So we can't see the visual light. Normally, if you are a little bit more closer, you can see here some hot spot, very small. This is from the bulb itself because the bulb is heating up and have a higher temperature, and then we can see it. But here in this distance and everything, we didn't see the bulb. It's black on black. So the black bulb on the black wood, both is heated up to a higher temperature, so we cannot see the bulb itself. But there's no effect from visual lightning. But very easy to detect the person here in the background who's walking by. Very simple. And that was also the main reason and purposes for thermal technology to be developed for security market. I mean, for sure, the beginning of thermal imaging and security was the military purposes. So they had ideas and they need to know how to detect persons in completely darkness, how we can do that. And thermal was a very good solution for that. And still today, this is one of the biggest thermal advantages, that we don't need any kind of visual radiation. So there's no sunlight needed, there's no visual light needed, no bulbs, no lamps. We can get information out of the field of view on day, on night, on bad weather conditions without any illumination. So this is one of the biggest advantages of thermal technology. Another advantage could be an advantage and also a disadvantage in the same time. On a typical visible camera, a visible detector, which is the CMOS or CCD sensor, can create up to 16.3 million colors. That's very good because you get a lot of details, especially in the front and in details. You get a lot of small details and many different various in colors, just for the grass, for example. But what is very nice for details and on closed distances can be very critical for longer distances, because in longer distances, it's a kind of blurred image. You see, maybe that's not really possible to see. There's a person in 250 meters, but by the large distance, the different colors on the person, on the surround is nearly the same. So it's invisible for the visible camera to detect on this range. With a thermal camera, we are not trying to getting up to 16.3 million different colors. We have just 8-bit. So 8-bit means 256 different colors or different gray shades or different segments or steps. So we have much less details also in the closed area, but in a larger area, in a larger range, we still have much more contrast between a warm object and a cool background. And so the typical detection ranges of a thermal camera is much longer than the typical detection ranges on the visible. And sometimes when I remember the first times where I deal with security cameras was 94, 95, something like that. No, sorry, wrong, 98, 99. And at that time, you need to, if you want to protect like 1 kilometer of fence line, you need to build every 30 meter a pole with illumination and with a visual camera. With a thermal camera, you just need 1 or 2 cameras for the whole range. So for sure, the cameras was much more expensive than the visual cameras, but under the line, you didn't need so much cameras, poles, equipments, groundwork, cables, licenses, so that the final project to protect the fence was much cheaper with the thermal. And this was the entry point of thermal technology into the commercial market. Before it was just for military purposes, for heating, searching rockets or anti-air defense or large border projects and military purposes. And over the last 10, 15 years, the price of thermal technology was dropped dramatically. My first thermal camera, which I had in my hand, was like 15, 16,000 euros. And today you can buy thermal cameras for 250 euro. You cannot use for every kind of application, for sure. It's very limited in features and functions, but you can buy a full thermal camera for $200-300. And there's a big difference in the last 10, 15 years. On the left side, you see some clip from an IR camera. And on the right side, you see some clip from an IR camera. Both camera technologies are working with infrared light. And in security, very often the people said, okay, IR camera is the camera, the visual camera with the IR bulbs around. Yeah, that's true. On the right side, it's also an infrared camera, but we said not infrared camera, we said it's a thermal camera because it's not working with the infrared light of the near infrared, where a visual camera is working with. It's working with a long wave infrared. And the long wave infrared is a thermal light. So don't mix it up. I remember some customers calling me and said, why your IR cameras are so expensive, like $1,000, $2,000, $3,000. I can buy IR cameras on the internet for $20. I said, yeah, but it's not the IR we do. For sure, Hikvision is also doing IR cameras, but these are so-called active infrared lights. That means you have the IR bulbs, which are sending out the infrared light in the near infrared spectrum. And this light is reflected on the object and goes back to the camera detector. And it's okay for some application, it's totally fine and good to use. But on longer ranges and also with weather conditions, etc., it's the thermal cameras have still a big benefit compared to infrared cameras. This is an example which I made a couple of years ago. On the top of the image, there's a so-called low light camera, which is a 2 microlux camera, which is similar to the Darkfighter. And on the bottom, there's a thermal camera. It's not from Hikmicro, but it's already a few years ago, just to see the difference. And even with a low light camera, you are not able to get enough image contrast and image quality in all areas of the image. In this example, the distance to the human which was staying there is like 150 meters. And for the low light camera, a big problem was here that we have a lot of light in the background. And yeah, you see it here up there. And we have a couple of light in the front. And in between, there's some more darker area. And the dynamic range of these low light cameras are not enough to create everywhere in the image enough light source to get all contrast. And in the thermal, there was not a big deal. The person walked by and easily to detect. So still, the thermal technology have a couple of benefits compared to night vision technologies or low light technologies, but the low light camera is getting better and better over the last years. I'm very impressed all the time when I see a Darkfighter or Darkfighter X camera, how they perform in really darkness outside. But still, thermal cameras have some really nice benefits. One of the benefits, additional benefits, advantages, is the external weather conditions, environmental conditions. When I joined Hikvision, my first step, I got a catalog for thermal products, and I read through the catalog, and there was a one set inside. Thermal cameras are not influenced by any weather conditions. And so I go to my boss at that time and said, hey, we have to change this. This is wrong. we have an effect to thermal cameras, but not so strong like on visual cameras. But if you said there's no effect, this is totally wrong. And if some of the sales guys is telling this to the customer trusts him, and then he found out under very heavy rain conditions, the range is limited. There's an effect, so he will not trust us anymore. So one of my first steps was to say we have to put all the catalogs we had in the warehouse, the printed hard copies, and we have to put it in the trash, and we have to rewrite the marketing brochures. Because there is an effect from weather conditions to the thermal image. But if I compare to visual, if we have a 100-meter range and we have a perfect weather conditions and we have a clear image on visual and a clear image on thermal, and now we have really heavy fog, and I know in UK you have a lot of rain and fog and not so nice weather conditions. On a visual camera, it can be reduce the range up to 10 meters or even less. And on a thermal camera, you still have a much more range. It's maybe reduced to like 80 or 70 meters, but still the range is much longer than on the visual camera. And here just some samples which I'm collect over the last 10, 15 years. I'm sorry. Okay, I forgot to switch off one of the phones. So now it's done. This is a picture, a visual picture from, we called it, how's it named for? Smog? No, it's not smog. It's, yeah, it's like in the morning you have this kind of dust and smog inside the air, and below there's a thermal image. This sample is already 10 years old, so it's older thermal technology, or not the newest generation of thermal sensors, but this is just an example. This kind of fog, and it's not really affecting the thermal image. On the right side, this is not fog, and this is not rain. This is sand, and this is from a picture from Saudi Arabia, from a sandstorm. And in the visual image, they were not able to see the traffic flow, and they are not able to control the traffic flow. And with a thermal camera, you see much more clear image about the lanes and how many trucks and cars are on the lane. But this is that's not water, it's sand. So it's a solid material in the air, and still we have much more information to cover. So we have a much better range. Yeah, if I have not enough light, or if I have not a good image, and so what can I do to improve my detection? One thing is, if I use visual cameras, for sure I can use lights, so illumination, but this can be very expensive to place it every 30, 40, 50 meter, 10,000 lux of illumination. So it's a big cost, and I think the electricity costs in UK are also knowing only one direction, and this is up. So that's a lot of cost, but also sometimes it's completely impossible to do any kind of illumination, like on a lake, on the ocean, on the North Sea. There's no possibility to implement illumination. And impractical. Impractical means, I mean, it's in theory it's possible, but it's not practical to do. Like when we have when you have a factory here in some area close to the city, you are not allowed to place strong illumination around the fence, because then the whole neighborhood have a bright time all over the night. So it's not allowed to use this kind of strong illumination on the fence line. So then a good solution can be image intensifier. Image intensifier are known as night vision systems. These are these samples of the green images. The problem of night vision systems is that you need a little bit of light, visual light. It could be coming from the stars, from the moon, that's okay, but you need a little bit of light. And then it's exposured up to 40,000 times to create some information. And this information are useful, and you can see much more than when you just look with your eyes outside, but you don't have the contrast. And so you have not the ability to detect quickly a person. And these are just a few samples: night vision technology and thermal technology. And for sure, the thermal technology gives a much bigger contrast. And as I said, we don't need any kind of illumination. And the other way, illuminated infrared cameras, IIR cameras. This is why I talked the few slides before. The two video samples, these are IR cameras, which are based on active infrared. That means you have a IR LED source, which is sending out the infrared light. This is deflected, reflected, deflected from the object and goes back to the sensor and can be then displayed as a, to create a better image. From this infrared light, I have some own experience. I use it in my small garden. That's fine. From the size, from the area, it's good. But one thing is, this IR bulbs needs a lot of energy, so it's a kind of additional costs. And the second is any kind of insects and spiders. They love the small temperature. I mean, it's IR light, so it carries energy and heat. And all these kind of insects and spiders and flies, they love this warm temperature around. So you have a lot of insects around the camera when the IR lamps are on. So this is not so nice. So buying thermal camera is the best solution for everything. So some really physical basics. Electromagnetic spectrum. I think all of you know the electromagnetic spectrum. We have it in school in the 6th or 7th class. And the electromagnetic spectrum is divided in several wavelengths. In the middle is the visible range. The visible range is related to the evolution. Our detectors, our eyes, are dedicated for the visible spectrum. You have electromagnetic waves with a longer wavelength and with smaller wavelengths. The smaller wavelengths are more energized. They can carry more energy. So UV light, everybody knows, if you're going out in the summer, too much sun, you get burned your skin. And this is just one example. You have the UV light, and if you go even lower in the range, in the wavelength range, you will have the X-rays, and even lower you find the gamma rays. And for sure, they are much more dangerous than UV light, visible light, and also infrared light. Above the visible light, we have the long and very broad infrared spectrum. And above the infrared spectrum, we have microwaves, radio waves, TV waves, etc. As the infrared spectrum is very broad, it's separated in different subfields. And these subfields, we have the near infrared, which is a typical IR camera. Then we have the short wave infrared, medium infrared, long wave infrared, ultra long wave infrared, and far infrared. Our Hikvision standard visual cameras are working in the visible spectrum and in the near infrared spectrum. You can easily determine it when you have an IR camera. You can see the IR lamp and you find a nanometer value behind. It could be 680 or 740. There are different technologies for infrared bulbs. And this is the wavelength of the near infrared, which is used for the IR lamps. But the thermal camera works in a spectrum from 8 to 14 micrometer wavelength. So it's much longer wavelength and less affected by reflections and visual effects. And it's very, compared to the other technologies, it's pretty easy to produce, and it's cheaper, the production costs, compared to mid-wave and shortwave. There are also mid-wave and shortwave cameras in the market, but they are very expensive and very complex and not time of the today training. And for the volume market and mass market, the long wave infrared is a common bandwidth which is used for thermal cameras. Easy sample of a thermal image. On the left side, you see it's from the visual camera. You see there's a coffee cup filled with hot water. And after a while, when I look with the thermal camera onto this coffee cup, I see a various bunch of colors. Normally, when I think it's a ceramic coffee cup mug, the heat or the temperature around the coffee cup must be everywhere the same, because it's the same material, it's hot water inside, and it must be hot everywhere outside. And if I'm touching it, I can feel there's everywhere the same heat, the same temperature. But if I look with a thermal camera onto it, I see areas of very low temperature, but not low temperature, low radiation, and areas of higher radiation and areas in between. So, and this is a very typical effect of a thermal image, very standard thermal image, and how thermal technology works. First, thermal technology, the thermal detector looks only on surfaces. We never able to look through something, except if it's germanium or very thin of plastic foils. But we are not able to look through a paper or to look through a wall or a glass. This is impossible. We only looking to the surface of an object. And in this example, what's happened with the two different stripes of tape, we change the surface by material and by physical properties. The normal surface of the coffee cup is ceramic, but we have another tape on, which is a black duct tape. So this very strong black duct tape. And we have a tape which is covered with aluminum. So we have now, instead of looking to the ceramic, we have three different materials where we're looking to. We have the ceramic, we have the aluminum coated tape, and we have the duct tape, the black duct tape. And as I said, the thermal camera is making the image out of radiation. And the radiation of an object is related to different parameters. And these parameters are the temperature itself, but also the material properties. Like if it's black duct tape, have a very high emissivity. Aluminum have a very low emissivity. So if you have some material with a high emissivity grade, it's have in the same time a low reflection grade. And the opposite, aluminum, low emissivity, high reflection. Black duct tape, high emissivity, low reflection. And what we see here is a variation of emissivity values from different materials. And on the right side here, you didn't see the radiation from the coffee cup. You see the radiation which is reflected on this aluminum coated tape. And for sure, this coffee cup was staying indoor in the cafeteria in our Hikvision office in Hoofddorp. And what we see here is the surrounding temperature of the room. And normally we have AC control, should be like 21 degree, 22 degree maybe. So this is what we see here. We see the background temperature because it's reflected on the surface. So not easy to use this value because we don't know exactly the emissivity rate, so we cannot calculate the real temperature. It's complicated, but it's like it's a thermal mirror or thermal reflective layer. The black duct tape have a very high emissivity of at least 94%, so 0.94 emissivity value, just 6% is reflected from the surround. So this gives us a very clear and a very easy method to use this area to check for temperature. And we see it's white, so this is the hottest area. And if I put in my cameras, I have the measurement functions like point, line, area. And if I put an area over the black duct tape and show me the highest temperature, I will have nearly the right temperature because the emissivity is very high. I can change the emissivity value in the software as well to make the most accurate calculation to the absolute temperature. Why this is so important? If you understand this principle of the physics of thermal technology with the emissivity and reflectivity on different materials, then you are able to interpret a thermal image. Otherwise, if you're not thinking in this way, you have many, many mistakes in interpretation of a thermal image. Quick example. This is a thermal image. Let me quickly check. Is there no open questions, no answers? Okay. It's a very simple example. This image, the thermal image, I got sent from one of our guys in Amsterdam. And he sent me the thermal picture and as well the visual picture. And it was a summer day in Netherlands, 30-degree air temperature, sunny day, no clouds. And he saw in his recordings this truck. And the truck is a food truck. So it have it's a cooling truck. So it has this kind of sandwich panels for the box. And he said to me, Marcel, I have some question because I cannot understand the surface, the roof of the box of the truck is for a couple of hours in the direct sunlight. And normally if something is in the direct sunlight, it heated up more than, for example, the sides. And why it's so cold and black here in the thermal image. And I said to him, yeah, you are right. If you touch your hand on the roof, you will burn your hand. On the side, not. So the real temperature is more warmer on the top than on the side. But the thermal image gives only the information about the radiation of the objects. And when I look on this image, I have to think about the viewing angle on the surface, and I have to think about the reflection angle. I was not there. I have no idea about the exactly material on the roof, but I think I know what it is. But what you can see here is not the radiation from the material on the roof of the truck. What you can see here is the reflection from the sky. And so that means we have on the truck some material which have not so high emissivity, but a higher reflectivity. And then I didn't see here the own heat radiation, that I see the reflected heat radiation. So viewing angle, the reflection angle, and when I compare this to the image, it must be the sky. So, and the sky, the clear blue sky, I think the persons who have made some long distance flight, they can remember when they're sitting in the plane and you are on travel height, like 10, 12,000 meters, you see the monitor, time to destination, accurate, blah, 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 speed, over ground, outside temperature. And on this outside temperature value, you will find normally between minus 55 and minus 70 degrees Celsius. And this is the typical temperature in this height. And when I take a thermal camera and point it to the clear blue sky, it doesn't matter if it's winter time or summertime, or if I'm in Saudi Arabia or I'm in north of Norway. When I look into the sky with a clear blue sky with a thermal camera, I measure typically around minus 60 degrees Celsius. And on a clear blue sky, for sure, I have this kind of reflection on reflective surfaces. And this is what's happened here. I just see the reflection from the sky on the surface of the roof of the truck. So it gives me some, yeah, I mean, it's a wrong indication, but for sure I know the physics. So I said, okay, if it's the same material then on top and on side, I can measure the temperature on the side, for example, and it should be more or less the same temperature on the top as well. Maybe it's heated up a little bit more on the top, but it's not so complicated. But the same effect of this kind of reflection we can see in the windshield. It's more dark, and for sure, if it's on the ground and we have an air temperature of 30 degrees, it will be not that cold. This is on the windshield. And as well, we see it here on the sign. I don't know if it's a Volkswagen or Mercedes, whatever. But you see that this is the sign. I think it's a plastic part covered with chromium. So it's also low emissivity value. So it's high reflective. And we see here also the sky. So we look viewing angle, reflection angle, and we see the sky reflection. And this is also one of the points that this kind of image is not very good in general. If I use this camera position on a perimeter protection, I have too many sky in the image. And you see it here, there's a lot of sky inside the image. And the sky temperature here, clear blue sky, minus 60. Cloudy sky, when I measure to the clouds, and the clouds are very how's it called in English? Dense. I think the cloud, the rainy clouds and something, they're very dense. So the radiation from above, from like 10,000 meter atmosphere, it cannot pass it. So what we see then is we measure more or less the air temperature and the air temperature on the ground. So you have big variations in contrast then of the image. If it changed from clear blue sky, -60 reflection of the sky to air temperature, like 20, 30 degree. So you have big variations in contrast. So strong suggestion, try as less as possible of the sky into your thermal image when you install it on a perimeter to look through the fence. There's no need of looking into the sky. We want to see persons who's climbing over the fence or entering an area, but we don't look into the sky. For sure, if you make drone detection or something else, you have to look in the sky, but that's another kind of story and application then. And so the emissivity is influenced by temperature, by material property, or material type, but also you can have materials which have a very high emissivity, like glass, window glass, have very high emissivity, but the surface is very, very flat. And if you have a very, very flat surface, we have the problem with a directed reflection. I'm not sure how familiar you are with diffuse and directed reflections, but very simple. Glass as a surface is very flat. And when I look into a window, I see myself with a thermal camera. When I look with a thermal camera to a window, I can see myself. It's like a full mirror. If I use glass with this mechanical non-looking through or non-visible glasses, that means where you cannot look into or through the window. They have a mechanical scratched surface. And when I look with a thermal camera to that glasses, I didn't see myself because we have a very rough surface. So we have a diffuse reflection, not a pointed and not a directed reflection, a diffuse reflection. So not only the temperature, not only the material is important for reflections, it's also the surface roughness or the surface geometric. So there are many, many effects which have possibilities to affect the result of emissivity and reflectivity. But for sure, in this kind of online session, we not have the time to talk a couple of hours about just this one physical effect. But there's something more, but it's more related to test and measurement customers, where you need to find out, okay, is it 38 degree or is it 39 degree? On a security camera, normally you want to see if there's a person walking by or not, or entering the area. And sometimes you have the safety features with the temperature measurement, like everything above 70 degree needs to be alarmed because it can start a fire. There we don't need this kind of deep physical knowledge to set up this kind of cameras and to use this kind of cameras. But for test and measurement, sometimes it's needed to make selections between half a degree or 1 degree, and then you need to understand and to give the correct parameters inside the system. Another example, this is also from our office in Amsterdam. Now with the thinking of reflections and emissivity, when I look to the thermal image, you see here the window glasses from the car. For sure, this cannot be a thermal anomaly in the glass. The glass is one unit, one material, one surface. So when I look with the thermal cameras on, it must be a homogeneous part or object. And if I see something like this, viewing angle, reflection angle, there's a wall behind this or at the side of the parking slot. And on the wall is a barbed wire that you not climb it over. So this barbed wire I can see here in the window because viewing angle, reflection angle. So it's the barbed wire is reflecting into the glass. And for sure, it's not a thermal anomaly inside the window. This is impossible. Also, what we can see here on the cars itself, you can see some sharp line through many different cars here. One side is cooler and one side is warmer from the radiation. More heat radiation, less heat radiation, less heat radiation, more heat radiation. And for sure, that's the same like on the glass. It's one unit. I have one piece of metal. Could be lacquered, could be coated, whatever, but it's one unit. And you cannot hear cold and hear hot. That's impossible without a temperature isolation in between. So this is physical not possible. So if it's physical not possible, it must be a reflection. And if I look with a viewing angle to the top of the car, and then I go to the reflection angle, I can see here our warehouse, the Hikvision warehouse, ended here up. So, and when I look to the cars, this, I see the reflection from the sky. And this is a reflection from the warehouse. So it's exactly the difference or the change between the warehouse and the sky, which I can see here on all the cars. So if I move my camera point position 20 meters to the right or to the front, it's a complete image change because I have another viewing angle and another reflection angle. And this is basically typically what you have also in the field when you do the installation for perimeter protection. Sometimes you need the camera move a little bit more up and down, left, right, to create a better image without reflections. Another thing what you can see here on the image between the wheels and tires. Tire is rubber, wheels are metal. So you see a different kind of emission of or heat emission, heat radiation from tires and wheels. The metal looks cooler, the tires heating more up, create more or heating up more and are able to release the heat as well more. So sometimes we got the question then, what's happened if I have a person, which is around 37 degrees, is walking on a ground, on a street or whatever, and the ground has the same temperature than the object. So it's like in a thermal thinking, it's a white object on a white surround. So that means white on white, we cannot detect. But 20 years ago, or 15 years ago, you need to set up every single camera exactly in brightness, contrast, and different auto gain control settings to find the best possible setup. Today, most of the cameras have very nice algorithms and automatic algorithms to change the auto gain control and wide dynamic range and to get the biggest contrast out of it as is what is possible. And the VCA is even smarter than our brain, and our brain, for example, here on the right side, it will take few seconds before we realize that there's an object. But the VCA needs around 10 to 12 different colors on the object to determine there's an object. And in this example, there are more than 20 different gray shades on the object. So the VCA will detect this person, and latest we detect the person when the person is stepped out to get to the cooler background. And since a couple of years, I didn't have really the case that we were not able to get enough contrast in some application, in some installation. But in theory, it's possible when you have an object which has the same radiation than the surround, it's white on white or black on black, you can't see it. But this is a theory. In practical reasons, we have so many different materials with different temperatures and different physical properties that you always get a contrast out of it. One thing, very important, because this happens very often. At my previous time, I was very often on customer side and do the setup and configuration of the cameras. And if, for example, on this image, if I did this configuration, the image looks very clear, very sharp, very nice image. It was Sunday, it was on a sunny day, dry day, everything fine. So you call the customer and said, hey, I set up everything, and the customer said, well, perfect, approved, bye-bye, you can go. So you jump in your car, driving 6 hours back home. Half of the way down, you get a phone call, your customer is calling you, turn around because the image is scrap. What? Image is scrap. Did you change something on the parameters? And then they said, for sure, they said not. And then you ask, okay, what's happened? Starts to rain? Yeah, it starts to rain. Ah, okay, that's a problem. And then you have to explain him what's happened. In dry situation, we have glass, we have metal, we have painted metal, we have stones, we have I don't know, gravel, no, what's called it, whatever. We have aluminum parts, we have plastic parts, we have asphalt, stones, different stones, we have metal pieces, we have many, many different materials. And all the materials have different properties. And then you have a big contrast. But if it now starts to rain, all the surfaces are covered with water. And as I said, thermal technology is something which looks only on the surface. Before, with a nice contrast, with a very great, nice image, clear contrast, because we had a lot of many different materials where we're looking to. If it starts to rain, we look only on water. And the only difference we see is that some of the material have a higher temperature because before, or the material inside is different and have another heat transfer. As I said, stones and wood are easier, or they hold the heat much better than a metal piece. And if some water drops on the metal piece, it releases the heat very quickly and gets cooled down. And so that's 100% normal that if you have a clear conditions, you have nice, crispy, very nice images. But if it starts to rain, it gets more blurry, more homogeneous. And many customers then ask, we have problems with the contrast and the image looks so nice yesterday, but today looks much more worse and blurry. There's maybe something broken or something. For sure it's not. It's just a physical effect where we have no influence to it. But trust me, if a person is walking into the scenery, he would dramatically have the contrast and you can see the person. It's just related to the water surfaces. So this is ranges. In the 1986 or something, Mr. Johnson, he was a professor and he had some order from the US Army to create some detection, recognition, identification schematic for thermal cameras. But at that time, the cameras were analog technologies and the cameras had no VCA system. They had the live operator was a VCA system. So there was person who's looking on a monitor all the time and said, oh, there's some person. With the VCA systems from today and with the digital technology and everything, this is not really comparable anymore. But the Johnson criteria are very common in the world of thermal technology worldwide. So all manufacturers are using the DRI scaling for the data sheets, for example, as well as we do. But they are not really practical. Normally today, you not have any live operator who's have to decide if there's a person detected or not. It's typically VCA systems which doing this. And the VCA systems, if you're using Hikvision one or you're using other third-party brands, then you have to follow the regulations they have, how many pixels needs to be on the target to be detected. And these cameras or these ranges are only usable to compare maybe manufacturer A, product A with manufacturer B, product A. So you can compare different products from different manufacturers to get an idea about the range. But for sure, a 25mm thermal camera cannot detect a person in 735 meters. The only thing what that means is that in 735mm distance, you have 1.5 pixels in horizontal on the object. This can be, these are only few pixels in the image. So basically that means there is something, but it can be a mouse in 2 meters or could be an elephant in 500 meters. Nobody can sort out. So it's not really usable in the VCA world with the automatically recognition and alarming. So the Johnson criteria are good to know, but they're not usable to use it in planning and in the decision making of which camera type you want to use. We have a very nice tool. I think Frank will talk a little bit about this later. He don't know that yet, but he will. The thermal design tool is the best planning tool we can offer to you. that you're using the tool and select the cameras, and then you get immediately the distance what is able to get. And the distance what you can get is related to the VCA features. So we have to be sure we are able to detect the human in that range. The Johnson criteria, nice to know, could be used to compare different manufacturers, but not usable for the planning of a project site. Some samples quickly. This is a simple application, perimeter protection. This is from South Africa on the left side, from some national park, wildlife protection. So here are some animals which need to be protected from hunters and from illegal hunting, etc. So long fence line, tripwires, easily, very simple application or projects. Another example here is from south of Europe. It's a solar panel or a solar farm, and they are protected, perimeter protected, also by thermal camera. So if some person is climbing over the fence and walks in, it will be detected, alarmed, and they can react. One of the disadvantages of thermal, I forgot. It's not possible to use a thermal video, like these videos, to identify a person. So that means if you're using just thermal cameras for perimeter detection, you need to think about what you are doing when you get an alarm. Otherwise, you have a nice video. There are some white spots moving around and climbing over the fence and stealing the solar panels or something else. And but you cannot send these videos to the police. The police will say, can be my mother, can be my whatever. So there's no identification possible. So you need to have some other activity after alarming. It can be that you switch on the light and use a visual camera, or you send out the dogs or the security officer or whatever, but you need to have some activity. Otherwise you have a nice video of a thermal video with the guys on it, but you cannot use for identification. And this is definitely a disadvantage, that we are not able to use thermal cameras for identification of person, but it's also a big advantage in times of GDPR. When you think about privacy policies, and you cannot use a visual camera in front of your house because this is public ground, it's not allowed to record any visual video there. So you can place a thermal camera there and you have no doubt it was GDPR, because nobody can really see if this is Frank or Marcel who's walking by. It's just a human. And so this is an advantage and a disadvantage in the same time. An application which has popped up the last years more and more is fire prevention and detection. To use a thermal camera to monitor an area about temperature. And this is especially in recycling centers, waste dump areas, other factories, storage warehouses for gases or other chemicals. It's very useful. And I don't know how many percentage, but when I think back the last 1-2 years, I would say like 40, 50, yeah, maybe 50% of the projects which was requested was related to fire prevention. And this is a very interesting topic. This is how it looks like. You can set up different areas, and you can set alarm barriers, and when they go over this alarm, so you got ID area 5 over temperature alarm, and maybe the shift manager get a notice on his mobile, or there's a horn which is going on or whatever. So it's very common and very useful application. And oh, hello. Excuse me, hello. Who's in my line here?
Marcel, I think it's maybe the video background noise.
Oh. Oh yeah, could be. Oh yeah, sorry, my mistake. There was some noise. It was sounds like Swedish or Danish. I think this is from Denmark. Yeah. the sample. So this is a typical, oh God, sorry. So this is a typical application, fire prevention and detection. So we're using the thermal camera for monitoring temperature of a certain area. And this is a very, very common application, and we got a lot of requests for it. Also requests about VDS, so certification from insurance companies. We have in France, we have the CNPP certification. We have made it already. So all the T versions of our products have the, we have a CNPP certificate. This is, the CNPP is a technical part of the insurance companies. And the certificate says that these products are able to measure stable this temperature range and with this accuracy, so it can be something similar in UK. I learned 2 days ago. So we have make notes to find out more about this kind of certification to maybe able to get also this kind of certification in UK. So this is a very common application to use for fire prevention. And in general, temperature monitoring is a big point. Yeah, temperature monitoring, it can be any kind of pump, engine, process control. You just put the camera there, and in this example, this is from a substation monitoring. So that they use a big, large PT camera, T version, and they use it to point from one object to another object to another object. And in every preset, they have different measurement features and compare these temperatures to see quickly if there's some connector which is according to oxidation or something is losing and increase the resistance. They want to it's a condition monitoring and preventing, how's it called? Forgot the name. Predictive maintenance. So they want to exactly know there's some issue with the temperature, so we increase the temperature. Let's schedule a stop and a renewing, a repairing before we got a blackout. And this is very common now in substation monitoring, but also I have a couple of applications where this is a pump control. And also I had now a project for a hospital. They have for the if they have a blackout, they have in the basement, they have some diesel engines for the power. And these engines needs to be preheated all the time, that they have a stable warm temperature, like 28 degree, I think, or 30 degree. They have to hold and to heat the engines to this temperature that they can immediately start and create the energy. And they are also temperature monitored now with a small camera, our TA21. They just placed it in front of the engine and measure the temperature of the engine on a larger area, just to know that the heating is working, so the engines are able to start immediately when it's needed to. So there are many, many possibilities for these kind of features of the cameras. These are only some common applications, but I've seen so many different applications for this kind of technology. I think that was enough with some basics about physics and thermal technology. Let's now have a look to the products. And when I joined Hikvision, we had 2 different products for thermal, single lens bullet and a dual lens bullet. But today, for sure, we have a much bigger portfolio. We have products for every kind of application and need. And this is a product set up for the security part. We have the small turret, single lens with a small resolution, with small lenses for indoor use, but also for outdoor use in a small dedicated area. We have the B spectrum cameras, the turrets, like with the visual and the thermal. The standard bullet cameras, single lens, so only thermal, but also we have the B spectrum with both. Then we have the larger bullets, because we have lenses of 50 and 75 millimeter up to 100 millimeter. For sure, they cannot place in the small housing, so we have the biggers. The technology behind all these products is exactly the same. They're working in the same way. The only difference between these products is the resolution. So the sensor pixels, how many and how big is the sensor? We have 160, 120, 384, 288, and 645, 12. And for some products, we only have the 160, 120, for example, for indoor, for short range, and for cost reasons. But other products like the big, we call it Big Mama, the stable PTZ. This is a camera which is only available in 645, 12, because the camera with a PT unit and with a large lens, we have here a lens available up to 230 millimeters. So it's this kind of lens, and it's a vario, so it's a zoom lens, a full optical zoom lens in thermal. So the price reached easily 80,000 euro or something. And for sure, it doesn't make sense to make this camera in a low resolution for short range. It's not needed. So we have this entry-level products, then more or less the standard level products, and then for other applications, some smaller dome, the 5-inch dome and the 8-inch dome, larger PT camera, and some special ones like anti-corrosive coating, anti-corrosive stainless steel housing. And also we have a ARTEX and IECX proofed camera for explosion proofed where it's needed, like in mines or petroleum industry, oil industry. Sometimes you have areas where you need to prevent from fire and fire detection, but you need to have X-proofed products. As I said, from the technology, it's all the same. We have the different types. Sometimes the people cannot use a visual camera, so they cannot use the B-spectrum cameras. They have to use single lens thermal, according to GDPR, for example. Yeah, the rest of the products, which is the right product or something, it really depends on the application and what the customer wants. The big difference between the dome technology and the PT technology is with a dome, which is mounted up, you have the possibility to look in the horizon or horizontal position, and you can look down. So down, horizon, and a little bit up. A PT camera is mounted more down and looks horizontal and up, but not down. So it really depends what you have to do, and what is the application where you have to use this kind of product. I will not go through every single product, doesn't make sense. This we have on the website, or if there's any question or more detailed question about the different products, data sheets are available on the website, but also the sales guys in UK, they know this normally, and they can help and support you. Otherwise, we have another business development manager, the Frank, he's also in line here. He can also support in this way. And basically, it really depends what you want, what is your budget, what is your range and area and application. And then we have to find the right product for this use. One special product is a smart linkage. It's a fixed single lens thermal bullet with a visual dome. And so you have a thermal view, like on a fence line, and you look with a thermal camera, and if you detect some person crossing the fence, you can identify and you can track with a visual dome. It's specially for perimeter detection. But everything else is, depends if you're using on a fixed position or on ultra long range, like the stable PTZ. We can easily go up to 4 or 5 kilometer detection with a 230 millimeter lens. Other products which are not in the focus of security and safety are the test and measurement products. So for building engineers, electronical engineers, or like the TA21 camera, cube camera, for monitoring of pumps or other heat-related, temperature-related products and temperature-controlled products. The same we can use with the T-series cameras. The T-series cameras have the similar look and feel like the security camera, but the temperature calculation inside is much more accurate and the temperature range is wider. The normal security cameras can measure up to 150 degrees only with an accuracy, long-term accuracy of ±8, which is totally enough for many, many safety applications. But if you need to measure higher than 150 degree, or you want to have a more stable and more clear measurement where it's more sensitive, the T versions, the T version bullet, the T dome, and also the TPT version have ±2 degree accuracy and can measure up to 550 degree. So if it's needed, then we have the T series cameras as well. Other products, thermal products, which are not for measurement, and this just images. So this is only look and you look through, like the monocular or binocular. This is for hunting, outdoor, adventure, security officers, border patrol, police, military, army, whatever. So this is, we call it commercial vision products. This is an economic product. It's 160 to 120 resolution, so very small resolution, but also very affordable price. And it can go up to the more professional binocular with with a laser rangefinder. This is a military product and easily reach 25,000 euro. So it's a big different product range for monocular and binocular, but they are all imagers. They are not able to measure temperature. The rifle scope, this is the old type. We have a new one, but rifle scopes are always a point of discussion depending on the weapon law in Europe, and especially in Germany, Switzerland. The weapon laws are different to Netherlands and UK. So in Germany, this is the rifle scope is official weapon, and you need a special license to buy it and also to sell it. So we don't have this product here in Germany. But in other areas, you can sell this and you can buy this to use it for hunting or for fun, whatever. But this is basically, it's from the technology side, it's like a monocular, but with a rifle mount and with some mechanical changes to be able to use on the rifle, because with the energy, when you shoot, you create a lot of back energy of the bullet. And these vibrations and mechanical movements need to be covered. So the design is different, but from the technology, it's the same. If you are not happy with all the products we have, we have also the core itself. The core is a small part where you have the FPA sensor and some readout, and we can put the optics on, and then you have a module, a core, which you can then implement into your product. So if our product's not fitting your need, we can also offer just the thermal core, and then you need to implement this in another hardware, in another housing for your application. So I need to check one thing. Where is I didn't see the question and answer. Michael, are you there?
Yeah.
Okay, good. Yeah, my computer hang up a little bit. Okay. So for the rest 10-15 minutes, we have here a collection of successful cases, just to give you a little bit an idea where thermal cameras are used. And I don't know exactly how many slides these are, but there's a lot of slides just to look through to see where thermal technology can be used. And this is very simple. This is a high-level residence in South Africa, which is protected with a electrified fence and a large fence, but also with some thermal cameras to prevent intruders from moving into this residential area. And in this example, we use the 26 series, so the B spectrum bullet cameras, plus 4 pieces of the 21 single lens thermal cameras, plus recorder and the management software. Very basically and simple setup, but easy to cover the needs. This you see already, this is from South Africa, from the national park. It's not really a farm. This is one of the national parks in South Africa. And they had the problem with illegal hunting of the wild animals. So they want to have the protection. And we use a lot of single lens bullet cameras on this application. I think this is from UK, an example from a G4S car shop in BMW, just to prevent from intrusion. And this is an example video to see how it looks like. And it will be alarmed if somebody climb over the fence or entering this area around. Because on a car dealer, you have for sure the cars, which are expensive, but normally the cars are not stolen so often, but components like the tires there, or they break into the car and take out the navigation and radio system and spare parts and all these things. So this is a typical simple application to prevent from theft. Also, in this video, we know from the solar plants in Italy. The reason why they put it in Italy, it was 2000. I think it was 2017. In the end of 2017, they make some. If you have a solar plant, you have to protect the perimeter with a thermal camera. It was not really by law, but by some pressure from the insurance companies. And so we had a big boom for perimeter protection of solar plants in Italy for 1 year, and then it was done again. Today, so the solar panels itself, the value of a solar panel is not so high anymore. In the past, it was very expensive, and every host of the solar plants, they built a lot of security and safety. But for example, in Germany today, when you build a solar plant, you have a, I don't know, 40 centimeter or 50 centimeter of fence, and that's it, because the solar panels are not that high value. It's more critical to the, how's it called, the AC/DC changers and transformers and the cabling. This is from the value itself for theft, it's a bigger value than the solar panels actual. So, and this is different in the different regions of Europe. And I don't know if you have so much solar plants in UK. I think whenever it's the sunshine, so there's no solar plant needed. I'm joking. Every time I'm in UK, it's not sunny, so it's always raining. But this is just an example about the perimeter protection of a solar plant. This is a sample from UK, from this temporary road shops and roadworks to prevent from theft, like the small, like all the tools and everything. This is an installation on a tower. But it can be also an installation on the building itself or on the fence line. Very simple to use. And as I said, with a thermal camera, you have less struggling with GDPR, which is a big topic in Europe. This is a very large project we had in 2018 in south of Europe, the substation monitoring. So they use the large PT cameras, T version 6266T, to measure the different components on the substation and make some maintenance schedule and to prevent from damaged parts or broken parts. So they do predictive maintenance on these large substations. Waste dump Denmark. This is, I don't like the video, but because there's some tree in front. In Denmark, in Copenhagen, there's some big difference to Germany, for example. In Germany, normally you have your waste center at your house. But in Denmark, every street have a central point of waste dumping. And in Copenhagen, they have a lot of struggles with, or they're struggling a lot with youth groups, gangs, which are going through the streets and lighting up and fire up this kind of waste dumps. And so the Copenhagen Fire Department installed a couple of thermal cameras around these waste dump stations to be alarmed as fast as possible if there's a fire. But this sample video is not so nice because the position of the tree is exactly in front of the fire. But okay, it's okay for a sample, but not the perfect video to show. So the fire picked up, and then the firefighters coming, and there was a single lens thermal camera, so the standard solution. trash site in Slovenia. This video we have seen already when I talk about this fire prevention and detection. So areas are protected with a thermal camera. We measure continuously the temperature, and if the alarm value is reached, we get a pre-alarm and an alarm, and then we can do some reaction. We have installations where the alarm from the camera is moved to a signal horn. We have installations where the alarm signal is going to make a push notice on the general manager. And also we have installations where the alarm message is going to the fire department that they can immediately react. So there are many different solutions. Also, we have one installation where the thermal cameras are controlling the control of the water guns. Many things are possible in this way, depending on what is to monitor and what is the needed application and solution from the customer side. Another one, chlorine production plant in South Africa, 2466 cameras. The 2466 is a stainless steel camera. So what they do is they're measuring certain areas here. Is that a video? No, it was not a video. So they use the thermal to detect the temperature exception of electrolytic cell and pedestal. So just fire prevention and temperature monitoring. Very simple application to set up this system is very simple, but very helpful, because when you look into the market, there are not so many technical solutions to which you are able to, where you can cover this without a thermal camera. So the thermal camera is very easy, and also I think from the price, it's a reasonable price to prevent this. So it's absolutely interesting and simple application, and it will be more and more standard, especially when the prices of the cameras are going lower over the next years. You will have more thermal heat sensors or heat cameras for temperature monitoring and alarming. Yeah, use the thermal camera to detect the temperature exception of gas tanks. This is a gas storage in France. They're using a dome camera. Why they're using the dome camera? Because it's more flexible, so you can use it on different areas of the larger stock, depending where you place your stuff and which you want to protect. So it's more flexible with a dome camera. Very simple application, monitoring temperature and alarm if a temperature is reached or increased. This is for forest fires in Turkey, but we had also some installation in Italy and Croatia, I think, as well, and Spain. This is to prevent from, or not to prevent, this is fire detection. This is not fire prevention. This is for fire detection, you need to have flames. So you need to have a fire. But with a 6266 100 millimeter C2L, it's a very 100 millimeter lens with 645/12 resolution. We can really cover a large area to see a fire. So for sure, what they want to do is they have a petrol mode of the camera. The camera is moving around from preset to preset, measure and check if there's some over temperature in some of the areas. And if there's an over temperature, there's an alarm, and then they can react and go through to before the fire is really widen or something, so they can early react and distinguish the fire as earliest as possible. Yeah, this is something, peat fields in France. Peat is, I think, the German, I think I know the German name, but okay. So these are different cameras are used here because this is from the material properties. It's a material which can easily heat up and get in flames. Also by ignition. So if you put a lot of this together and give them some pressure, it can self-ignite. So they prevent the whole area to get a quickly information if there's some over temperature and some increased temperature to react quickly to avoid from fire. Yeah, this is a test in France with an 8166 series, so with a big mama camera, and they do some fire detection test on 10 kilometer. So this is 10 kilometer distance, and it was some interview and some report in the newspapers in France. These are the guys from the different fire departments in France, and one was a overall general manager of the firefighters, and this is my colleague Frank, I guess. If I see the hair not existing here, this should be Frank. So they make some test and some demonstration and to show the possibilities of this technology to the firefighters. And there's a video on YouTube, on our YouTube channel, where you can find these samples and the video. So it's very impressive on 10 kilometer detect fire, full automatically with the system, very useful. Also to show to customers if they not really understood what is this thermal technology and what we can do with it. Okay, we already talked about this, temperature monitoring of substation components. This is a very special set. This I did. That was only a test, but this is also interesting. These are steel plates, and this steel slab has still a temperature of around 700 degrees. And when they are produced, they are stored outside then, and they got this number on it. And this number is important because this is the lot number of this. And there's a crane driver who have to see these numbers to pick the right ones up and place it on the right truck or in the right train wagon. And the problem is if there's a little bit of rain, and you see that's outdoor, that means the rain drops to the steel plates and it's evaporate, and you have a lot of steam. And so he's not able, with a visual camera, which was installed there, to see the numbers anymore. So what we did is we said, okay, let's take a T version camera, which can measure up to 550 degrees, that we are able to detect the lot number